Hello everyone, good afternoon. Welcome to the project engineering session. We have four rooms running in parallel, all with very interesting topics, as you could see in our agenda. And also, you are free from moving to each room as you wish. At the end of each presentation, there will be a Q&A session. You can make questions during the presentation, and in the Q&A chat that you can find in the right side of your screen with the question mark icon. As the chairperson of this session, we'll have Bruno Sá, and Bruno has a background in engineering and received his master in environmental engineering from Técnico, and also a master in chemical engineering from Instituto Superior de Engenharia de Lisboa. He has over 8 years of experience in oil and gas industry, mainly associated to the development of FPSOs and subsea projects in South America and Africa. Currently, he acts as a coordinator of the technical team for Bacalhau field on the development of the best technical options which optimize project value, ensuring safety and technical integrity. Please, Bruno, the floor is yours.
Okay, thank you, Joanna. Thank you for the presentation. We are in a very tight schedule, so I will proceed with the presentation of our first speaker. Our first speaker is Guilherme Martins, lead engineer at the Baker Hughes. He is an experienced subsea production system engineering, has worked across multiple disciplines in both technical and commercial support, with a bachelor in mechanical engineering from Federal University of Itajuba, a postgraduate in pipeline engineering from Pontifícia Universidade Católica, MBA in oil and gas business management from Fundação Getúlio Vargas, and over 14 years of experience in oil and gas industry. He is going to present the Petrobras WAG manifold development for pre-salt fields. Welcome, Guilherme. The floor is yours.
Hello, everyone. Thank you for joining. I will start to share the presentation. Okay, so everyone can see the screen? Yep. Okay, so today we are going to talk about the WAG manifold development for pre-salt field in Brazil. Let's start to talk about our manifold experience. We have a large variety of subsea manifold configurations on standard building blocks. More than 150 manifold suppliers. We have also template manifold, cluster manifolds, internal and external piping loops, vertical and horizontal jumper connections, move-pull installation manifold, skirt, monopile and suction anchor foundations, pipeline end manifolds, which means plain, pipeline end terminations with acronym PLAT, and riser bases. We have also diverless and diver-assisted connections. We have here a collection of pictures where you can see some of those examples that I just spoke here. Okay. So now let's go to the WAG manifold itself. The project overview. On 2014, Baker Hughes started the engineering phases of the WAG manifold for water or gas injection for the pre-salt fields in Brazil. Just a note to clarify, WAG means water alternated gas. So basically, we can inject water or gas, okay, to the field, the formation. Here is just a 3D module of our manifold. As you can see here, we have basically 4 VCMs to connect the manifold to the well, to the Christmas tree, and also 2 VCMs to connect the manifold to the platform. This manifold has a singularity where the design is based on modules, so we have a modularization here. I will explain that after in details, okay? Just to have an idea, I will present now the input data. The water depth for this project was 2,500 meters. Working pressure, 10,000 psi. The pipe ID is 4 1/16 inches for the header, 5 1/19 inches for the branch. The material trim is HH, corrosion-resistant alloy. And the hydraulic pressure, since this is a ultra water depth project, we have 4 to 5,000 psi. The design temperature is from 2 up to 70 Celsius degrees. And the design life is 30 years. Just let me change here the pointer to make it clear. Better now, right? So, the design characteristics. The dimension of this manifold is about 16 per 8.5 per 4 meters. This is for transportation, and this is also that's something that I will also explain after, okay? 16 per 13 per 7 meters for installation. The weight, the average weight is 150 tons for transportation, 215 tons for installation, 280 tons for operation. Okay, those are approximately dimensions. Okay. Structural design. So the WAG manifold was designed with mud mat foundation. The foundation and the structure were designed for all the phases of the life of the field. The lifting pedals and main structure are designed to handle all the installation and recovery loads. So basically, as you can see here on this projection, we have all the structure designed to handle the installation loads and also to recover. So the installation has a very robust design, right? It will not handle only the weight of the manifold itself, but also all the how can I say, when the manifold is installed, the manifold crave on the ground. So this structure handles all these extra loads to be uninstalled, okay, to be recovered. Pipeline design. So the pipeline was designed in compliance with ASME B31.8. The pipeline material is X65 with Inconel inlay to comply with the trim HH, right? Use of ASME curves on the branches. It maximizes our speed to delivery, okay? So, piggable header and mag injection on strategic locations to avoid hydrate formation. Here in this picture, we have a 3D projection of the pipeline. You can see here we have a dual header, right? And this header is piggable. To connect the two headers to make a pipe loop formation, we have a crossover module that is installed here to connect these two hubs, okay? I will show in detail after as well. Here you can see these two hubs connect the manifold to the platform, and these 4 hubs here connect the manifold to the well. So we have here some manual override valves, okay? And the choke modules are connected by a collet connector. Modularization. Now let's get into details of these modules. The manifold has basically 2 choke modules, 1 crossover module. Okay, let me go into detail. The choke module is this one, right? Basically, the choke module has the choke and all the flow, and have also the flow meter, and the flow control is made by this module and not by the Christmas tree. So this is a particular consideration for this specific project. Okay, so we have the chokes on the manifold, not on the Christmas tree. We have one crossover module here, this one that I just explained on the pipeline figure, right? It's pipeline 3D to connect the two headers. We have 4 export VCMs, okay? 2 import VCMs, you can see here in these pictures. We have 3 MTUs. The MTU is a acronym in Portuguese for umbilical termination module, okay? We also have 2 SCMs. So, main challenges for engineering. We returned of the manifold project line in Brazil after 10 years, so the team is quite new, and we have a technical challenge to update and adopt the global standard products for the specific requirements for the pre-salt in Brazil. The creation of the new manifold team in Brazil, the challenge of learning curve, and to adapt to the company technologies, culture, and requirements. We also have a huge challenge here on transportation. So the construction yard here in Brazil is far from the coast, and the manifold itself is a large equipment, right? So we have a road transportation module involved here. And the roads here in Brazil, we have this limitation here, 4.6 meter height and 90 meters width. So basically, if we go to our installation module of the manifold, the dimensions will be over this limits. So what we did here, we basically removed the side skirts of the mud mat and also the sub base. So basically, this is the configuration for the manifold for transportation. This manifold is installed over the truck here, okay? As you can see, we just removed the sub bases and the side skirts. It allows us to comply with our road configurations. As you can see here, this truck here is under transportation, and we were able to transport the manifold within the limits and still safe it, okay? Next challenge was regarding the project management. So during the project execution, we needed to have a construction yard development. And also, we have an unprecedented execution module in Brazil. The manifold was completely executed and tested on the construction yard. This was a successful module where basically we brought the 3D module and just delivered the 3D module to the construction yard, and they were responsible to take this 3D module and elaborate all the executive design to construct the manifold itself. It minimizes the loss and it speeds up the process, and we were able to deliver on time. So after all, we have our first installation on November 2018. The distance of coast is 200 kilometers, and the water depth for this first installation is 2,000 meters. Up to now, we have 4 of those WAG manifolds installed. The installation was a success. We didn't have any issues during the installation. Up to now, we have 1 manifold completely commissioned with all the VCMs and all the modules installed, and it was a success. And that's it. Let's go for the Q&A.
Okay, thank you, Guilherme, for the presentation. I just want to remember that people that want to make questions have to on the question mark in order to write the question. So I will start with one question that is for you. That is, please clarify the main reason for the Baker Hughes not consider yard fabrication in front of sea, similar to other competitors. Why not to develop a new structure supplier? If I can repeat if you want.
Yes, actually, yeah, the connection is not so good, and it seems that you are just cutting your.
Okay, so I will repeat. Please clarify the main reason for Baker Hughes not to consider yard fabrication in front of the sea, similar to other competitors, and why not to develop new structure supplier?
Okay, so basically here in Brazil, this manifold was fabricated here in Brazil, right? We don't have so many yards close to the sea. So actually, we have one. It was basically a matter of who gave us the best condition to deliver, the best price as well, as this is important, right? And the time frame was very important. It was very important for this project. So this specific supplier gave us the best proposal on the time. Okay. In other parts of the world, for sure, our construction we have other construction yards that they are very close to the sea. But here, specifically in Brazil, we have not so many. I could say that if qualified construction yard, we have only one. So probably on that time they were struggle and they were not able to supply on time. Okay, since we have a very tight schedule.
Okay, thank you, Guilherme. We have a second question. The question is, what type of valve do you consider as crossover model in order to avoid connection between headers? Could you inform the supplier of this valve? There is any challenge during qualification plan?
Yes. So for the crossover module, we have 7 1/16 inches valves. These valves, they are hydraulic actuated. Okay. And the supplier of these valves was ATV. Did I answer
Sorry,
your question?
I was mute. Thank you. No, I have another question. That is, we understand that Petrobras is the driving operator of this technology. Do you see other operators following the trend of using WAG manifolds?
It really depends of the demand of the field, right? Here in Brazil, we have a large demand to have the water injection or gas injection manifolds, especially if we are talking about ultra water depth project or for revitalization. I will not say about other parts in the world, okay? Because I basically my domain is basically on Brazil, here in Brazil. But it really depends of each field, so it's a very specific characteristic.
Okay, thank you.
One point. Let me complement the question for the valve. I just
Please
remembered
do.
that. Yeah, just remember that you mentioned about the challenge to qualify this valve, right? Yes, we have a huge challenge to qualify this valve, since this valve is qualified in accordance with our client here in Brazil specification, and not only as a world-class qualification, it's above world-class qualification. So the design of the valve is specific with several special requirements. The number for cycling is is much more than the API 16A and 17D. So the valve is very robust and was qualified with in a number of cycles much larger than the world class. So these are very robust valves.
Okay, thank you for that clarification. I have other question in here. Why is the choke installed in the manifold instead of the Christmas tree? What was the drive for this option?
This is a requirement that was made from our client. It's not from us, right? So basically, there's a client preference. They made all the studies and the flow assurance studies for the field, and they prefer to have the choke installed on the manifold and not in the Christmas tree. This is a specific requirement. It's just a client's preference. Okay.
We have time for one more question.
Okay.
I will show this one. So if I understand correctly, the technology is to handle 10,000 psi. But with several fields being now found on frontier conditions, how long do we need to wait to have 15,000 psi WAG manifolds, or is not an option right now?
This manifold was designed as per our client requirements. So basically, this is not a Baker Hughes, how can I say, internal product. So we just sold a product for our client as per demand. So we had a requirement, we had a material requisition from our client, and we brought all this requisition into a product. So the reality to have a 15,000 psi requirement is close to us for sure. At this time, we specifically here in Brazil, we don't have any requirement for 15,000 psi up to now, but we see that this is the future, right? Since we are going to even deeper water depth. So as long as we have this demand here, for sure we will be able to update our design or for new technologies and for new requirements, for sure.
Okay, thank you, Guilherme. Once again, thank you for your presentation. That technology, actually, for myself, it's quite, I would say, somehow familiar because we used to have that kind of manifold WAG on our field. I will need just time for Igor to make a quick statement, please. Igor, please.
Yes. Good afternoon, everyone. So thank you once more, Guilherme. So just to remind people to navigate in the platform that you're seeing. So in the top corner in the right, you have the selection options like video, audio, and presentation. So if you click in presentation, you can see the full screen and continue with the question option. So if you want to make questions for the next presentation, you have the icon with a sign of question, and you can drop your questions over there. So the next session that will be with Jose Plasencia, sorry. So will be held in more 3 minutes. So we need to wait a little bit and make a quick break. And thank you all. Thank you, Guilherme, once more.
Thank you, everyone. It was a pleasure.
Thank you, Igor. So we will wait 3 additional minutes to the presentation from Jose. Thank you.
Yes, thank you.
Thank you.
I just want to make a statement. So you, for people who are attending this presentation, you can perform your questions during the meeting without any problem. Just have to click the question mark button and proceed with your question. Then we will get those questions for the final of the presentation. Right now we are going to start with our second presentation. For that we will have Jose Plasencia, Project Manager at BHGE. He has a master's degree in flow assurance and a PhD in multi-phase flow from Norwegian University of Science and Technology. He has 15 years of experience in oil and gas, where he has held different positions in engineering consultancy and management. He has led development programs from R&D to product introduction, and is currently program leader in Subsea and processing. He's going to present the modular compact pump, a game changer in subsea boosting. Welcome, Jose. I will give you the word now. Thank you.
Thank you, Bruno. Can you hear me? Your voice was breaking a bit. I hope you can hear me clear.
I can hear you quite well. I don't know, there's something wrong with my microphone. I'm sorry.
Okay. Great. So please tell me if you can see my screen.
Yes.
Great. Well, good morning, good afternoon, everyone. I would like to thank Galp for this opportunity. It's really good to get a chance to show you a bit on our program, which is called the modular compact pump, which is a completely different way of doing boosting or subsea boosting in general. So this is a program that we have in our company targeting the qualification of this pump. But I would like to start talking about the challenges. So when we think about our industry challenges, and when we think about subsea development, well, we tend to think about large and complex subsea infrastructures laying in the seabed, and these actually have a huge demand on the topside facility in terms of equipment and footprint. And if we talk about subsea boosting, so subsea boosting has been a response to those challenges, starting from improvements on the process side, but also looking after cost reduction and footprint reduction requirements from the topside facility. But nowadays and in the future, this goes beyond the cost saving requirement. So we are now discussing and talking, and the operators are talking about emissions. So how we can reduce emissions and reduce CO2 footprint of equipment in general, from conception all the way to the end of their operation. And then we use every single opportunity, which can be size reduction of equipment or weight reduction, not only to reduce cost, but also to reduce that footprint or emissions in general coming out from the conception of this equipment. And it's not only on equipment, but just to give you an example, also on chemicals. So using chemical subsea is about production, is about transportation and also disposal, right? So then we are talking about the entire cycle that, again, as I said before, includes production, manufacturing in the case of equipment, transportation, logistics, and so on. So the concept on the modular compact pump that I'm going to show you, it's actually targeting also that new demand from the industry, and we believe it offers advantages compared to existing boosting technology. So when we talk about conventional subsea pumps, and let me just probably get a pointer here. So we're talking about well-established technology in the market that has been assisting production for some years already, but it does have some challenges. And here we see a module with two subsea conventional pumps. And if we focus on this module here, when we talk about conventional pumps, we're talking about a long rotating shaft that connects the electric motor side, or the generation of power, with the hydraulic side, where you have a set of impellers rotating attached to this shaft, and of course to increase the differential pressure of the fluid. But this creates some additional demands. As you have two sides, you need what is called a barrier fluid system, and that's basically having fluid inside the motor to avoid process fluid going inside the motor and basically damaging it. But this barrier fluid system has an additional requirement which goes together with a complex subsea umbilical. And this subsea umbilical goes all the way to the top on the platform, or FPSO, and it has an additional demand on footprint and weight capacity. And it hosts this what we call HPU and a sophisticated control module for that. So in addition to that barrier fluid system, we're talking about dynamic seals. A dynamic seal is basically a barrier between the motor and the hydraulics part, and it needs to provide sealing around a rotating shaft. So it's one of the most critical components in these types of pumps. So that's an additional challenge. And when we talk about rotating shafts, we are talking about rotodynamic limitations. So we're discussing about a long shaft with a couple of supports, which are the bearings, getting dynamic loads in all directions coming from the impellers. And that creates a limitation on how long you can have this shaft, and as a consequence on the maximum number of impellers that a pump can host. And of course that limits your differential pressure. So then you are limiting your differential or maximum differential pressure because of that. In addition, we can refer to what refers to the density of the fluid. So typically these pumps, because of this rotating shaft, require a minimum density in the fluid. So that's to dampen some vibrations, which are common. So as a response to this challenge, we have been working on this modular compact pump for quite some time already. And this is a completely different way, as I said, of doing boosting, and it is a barrier fluidless pump. So it doesn't require the barrier fluid that you had in the previous conventional concept. And it has a static shaft. So you see here, this is the shaft going inside, and it is completely static. But before we go into the details, this is what we call a building block of 4 stages. So this is a pump with 4 stages. You can see here 1 stage, 2 stage, 3, and finally 4. And this every 2 stages we have a multi-pin penetrator to supply with the power to every 2. So let me zoom in a bit to give you more details on this concept. So the fluid in this configuration comes from the left. As I said, the shaft is not rotating, and the fluid basically wets everything between the shaft and this white barrier, which we call the ceramic can of the motor. So therefore, all the bearings and the impeller and even the rotor part of the electric motor is wetted by the process fluid. This way, you basically avoid the need of a barrier fluid. That process fluid then, after going through the helicoaxial impeller, this configuration here, it's an helicoaxial impeller for multi-phase application. It goes into the diffuser and then into the next stage of the pump. On the outer side, as I said, you have the ceramic can, and you have the stator part of the motor. So then we have an integrated, rotor the rotor part of the motor with the impeller, and that way we avoid the need of a barrier fluid. So this has massive advantages. One of them is 40% lighter due to its compact design because of this integration of impeller with the rotor part of the motor. And also, you have smaller loads on the bearings, as you actually have individually controlled stages, having dedicated motors for each of them. So then you have a high flexibility or controlling RPM of each impeller, which is a big advantage, especially in multi-phase applications. So this is the concept and the benefits that brings the modular compact pump. So talking about advantages, this concept is fully scalable. So we are talking about replicating, or the option to replicate the stages as we wish to meet differential pressure or power requirement. So therefore you have really no limitation on number of stages, which in the case of conventional pump you have due to the rotating shaft and the loads on the shaft. On top of that, we can adapt, because of this, to changes along the life of the field. So this inherent capacity of adding stages also brings an additional big benefit, which we call inherent redundancy. So as you can replicate many stages, and as they are individually controlled, you can actually survive and continue operation of the pump with one failure or a couple of failures. You just compensate the RPM of the other stages, or increase the RPM to compensate for the lack of one stage. So if you compare that with a conventional pump, with one failure, with a single failure, you will lose completely a conventional pump. While in this case, you can actually have extra redundancy. And an additional benefit of this scalability is that if we're talking about an application where, for example, you have a 3 megawatt pump available and you need a 4 megawatt power, you will need to use 2 pumps to meet that capacity demand. While with this concept, you just add a couple of more impellers, and then you meet kind of what you need. So that is also an important cost saving from that perspective. An additional benefit, as I said, is linked to the elimination of the barrier fluid system. So here on the right side, you see the top side footprint demand from the MCP pump, while for the conventional pump, you will need double that capacity, basically or mainly due to the barrier fluid system. So of course, as you don't have barrier fluid system, you will also have a simplified umbilical, and that's aligned with all electric systems, which are the new trend in the subsea space. So cost reduction, I mean, all these benefits bring cost reduction. An estimate is around 25% lower cost in general. Again, this comes from different sources. One of them is the barrier fluid elimination, which at the same time brings the simplification of the umbilical that I referred. So on the right side, you see the modular compact pump power cable, and on the left side, you see the conventional pump cable that you would need. And imagine this from the emissions and CO2 footprint perspective. So just thinking about transportation and fabrication of a cable in bigger reels and bigger vessels potentially. So it does bring a big advantage also from the CO2 reduction, emissions reduction perspective. So a bit on the system design. A dual boosting station with the MCP would look more or less like in the picture. So on the bottom right side, you have the power cable, which feeds first a transformer. This transformer feeds power to the VSDs through wet made connectors, and at the same time, these VSDs control and feed power to individual motors on the modular compact pump, which is in white here. And of course, this comes into modules, and you have piping manifold, which is conventional in this kind of stations. So I told you a bit on the technology and the benefits it brings, and this has been a development that it's been on for a few years now, but has focused so far in the multi-phase version. So thinking about multi-phase version, we are talking about helicoaxial impellers and not centrifugal impellers. And on the path we have been going through is in 3 phases. Phase 1 was back in 2016-17 and it's been completed. So that time we built and tested a prototype, and this was in our facility in Bari, and we tested this pump up to 5,000 RPM and 80% gas volume fraction. So this proved to be a successful testing, and where among other things we actually verified that the polycrystalline diamond bearings are actually can operate with this process fluid around for cooling purposes. So an additional important learning was that we can really operate this pump with a failed stage by compensating or increasing the RPM of the other stages. So that's back to the inherent redundancy that I mentioned to you. So then phase 2, which has been also completed, was about critical components and sub-assembly testing. So here we did process fluid lubricated bearings testing. So we actually went beyond 6,000 hours of testing of these bearings, which was a good learning and demonstrating the feasibility of this concept. So we also designed the motor and power electronics, and we designed a pilot for the qualification in the current phase, which is phase 3. So we also provided case studies for our customers to evaluate feasibility of this concept in different project opportunities. So now we are actually in phase 3, which started last year, and it's about the qualification of the subsea pump to meet TRL 5. So the benefit of this scalable pump is that you don't need to build a 6 or 4 or 8 megawatt pump to qualify it, because its scalability enables you to build a 4-stage pilot to do this qualification. So that's the manufacturing plan for this phase, and then this pilot will go through submerged endurance testing and 1,500 hours of testing according to API and DNV standards. So, but that's on the multi-phase pump program, and we do see this technology as a platform for other applications. So the next step would be to have this helicoaxial pump, or what we are developing as an helicoaxial pump for a single phase application, and that basically targets possibly 2 main applications: water injection to increase oil recovery, and CO2 reinjection. And in the case of CO2 reinjection, as this is a pump, it will be for CO2 in supercritical conditions, which is a more liquid-like type of fluid. But what we can make use out of the multi-phase program and the qualification program we're completing. So it's actually quite a bit. So we will be using, for a single phase application, quite a few components, including the multi-pin penetrator. We will be using the motor part, the stator, permanent magnet motors, the motor can. So all that will be qualified and available for a single phase application. And also the bearings. So the bearings, due to the different geometry of the centrifugal impeller, will need to be slightly different in size and arrangement. Also the diffusers will need to change, as the diffusers are in this case applicable for helicoaxial and multi-phase applications. But so then basically I'm telling you we're missing the hydraulic part on the design of the centrifugal impellers, and that's actually something we have done quite a bit, specifically in topside solutions. So we have provided pumps with differential pressures of up to 540 bars, for example, for CO2 applications. So we really know that application well, with proprietary design and in-house expertise. And this type of pumps, again with pretty high DPs, are being delivered, like for fields like Tupi with Petrobras and others in the Middle East and the US for both CO2 and seawater reinjection. So implementing these hydraulics into the previous concept will basically fill in the gaps, and then we are basically talking about reusing everything outside this light blue boundary. So the stator motor, the motor can, etc. And we will be replacing everything which is within this boundary, which are the impellers, type of impeller, the bearings. You can see here the truss bearings, the synthetic diamond bearings that will need to change a bit due to the new geometry of the centrifugal impeller, also the diffuser as an example, but the rest will continue being the same. So that brings a lot of simplicity or a lot of lower complexity for this potential new development. So then, thinking about the MCP as a technology platform, we have a wide range of solutions and applications that can target different scenarios, and again, all of them target to have cost reduction, but above all now this CO2 footprint reduction of the equipment during its life cycle. So again, multi-phase application requires helicoaxial impellers, as we went through in details. For the CO2 application in supercritical conditions, we can tailor with centrifugal impellers, and we can couple that with subsea separation, which is an example here on our troll pilot. We can also couple that technology with water injection using, again, centrifugal impellers, and counting on our program on subsea water treatment. So we can inject water too for increased oil recovery applications. And also centrifugal impellers for low gas volume fraction applications, also that can be coupled with subsea separation. So this gives a range of opportunities to improve or to offer solutions in different applications. So just to close the presentation, some highlights on the modular compact pump. So then we believe this solution it's really targeting the new requirements on reducing emissions and also CO2 from both perspectives, from simplifying subsea systems and equipment, and also, for example, in an eventual application of reinjection of CO2, which has a very high differential pressure demand. And on the other side, just to highlight the benefits, which are again a static shaft with no rotodynamic limitations to the very high DP applications, and well, elimination of this dynamic seal, which is a key component prone to failure, and the inherent redundancy and operational flexibility that this scalable concept offers, together with this water fluidless concept to simplify the umbilical and reduce the demand on the topside facility. So yes, I will be happy to answer questions if there is any.
Thank you, Jose. Can you hear me?
Yes, I can.
Yes, good. So I will thank you for the presentation. I will pass you now some of the questions that have reached to us. So the first one is, considering the low price environment that we are now, can you elaborate a little bit more on the strategy to qualify this new technology under this environment?
Yes. So despite of the challenges, we are progressing well with this technology qualification. It's again for the multi-phase application, and we do have an interesting discussion with a customer, with an operator. Well, actually, few of them on this CO2 application. Again, we do see a big potential for this pump and its benefit to meet the targets, which having as main challenge is probably the high differential pressure of that specific application.
Okay, thank you. Thank you for your answer. We have a second question. Is related to the motor voltage. Where do you see the benefit on increasing the motor voltage, or do you there are any savings on this strategy?
Yeah. So the motor voltage the decision has been made on the basis that we do see low voltage being more reliable than high voltage. So we see a bit easier to handle higher currents with low voltage than high voltage. And after a total assessment and considerations on both options, actually the voltage has been decided to be 690 volts, for example, or in that range. And again, it's a reliability based decision, which in our experience and after discussing with some customers, I landed into that conclusion basically.
Okay, thank you for your question, for your answer. I'm just going to ask you to stop sharing your screen, please, Jose. We can go to the first question. We still have time for that. The question is, as you are aware, the biggest market for this MCP is the pre-salt on the CO2 separation. Could you elaborate on the strategy to increase the local content?
Yeah, I mean, we do have quite a bit of experience, and probably one of the more innovative projects being developed in Brazil on water treatment with local content. So I've been working quite hard with the team in Brazil in the past in trying to meet these local content targets, and with that experience, we believe we can do this new development on the CO2 application with the team, with a dedicated team from Brazil. So again, there has been lots of learning. That new development won't come from zero. We have this multi-phase development which brought quite a bit of learnings and already most of the qualified components in the concept or in the technology, and it will be a spin-off of that technology for that application. So we're confident on that local content requirement in a project like this.
Okay, thank you very much for that. We still have time for one more question. The question is, could you elaborate if there is any plan for testing this technology in flow loop?
In a flow loop?
Yes.
Yes, definitely. So we are doing testing in about a year from now after manufacturing of the pilot for the multi-phase version, and so that's coming as part of the ongoing program and as part of the CO2 application. I mean, we have been discussing about doing testing locally in Brazil, and but also we will have a CO2 flow loop in a facility in Italy, so we could potentially do that. So yeah, but the closest testing coming is the one in here in Norway actually for the multi-phase application.
Okay, thank you very much. Just a quick question. Can you provide the order of magnitude of the mean time to failure of these pumps?
Yeah, I mean, that has been an interesting question, because when we went through this concept and we evaluated different scenarios, this is a completely different concept in the sense that you can operate with less impellers and still meet, as long as you meet the differential pressure requirements. We're now in the middle of doing that estimate, because it requires a more complex estimate beyond this conventional qualification. So we are surprised with that reliability or availability that this concept can offer actually. And I would prefer to wait until we get these numbers to discuss that properly, but I am happy to answer emails and discuss this on a separate environment.
Okay. Thank you very much, Jose, once again for your presentation. Very helpful. I hope our audience is enjoying this also. Thank you. Now we are going to pass to our first presentation of today. For that, we are going to have Marin Abélanet. I hope I'm saying it right. Sorry for that. Engineering Director at Subsea 7. Marin has 35 years of experience in industry, 17 of which working with Subsea 7, having started as Engineering Manager of Africa region, and then moving to Engineering Director, first for the Asia Pacific region, and then returning to Africa region. Previously, Marin has worked at Gulf flagship Senem offshore, with major focus on offshore deep water development. With a presentation on Subsea 7 track record and experience on mooring system installation, please welcome Marin Abélanet. Marin, please, the floor is yours.
Okay, thank you very much, Bruno, for this kind introduction. I'm going to share my screen so that we can proceed with the presentation. Here it is. Can you see my screen okay? Bruno, maybe you can tell?
Yes, I can see it.
Okay, perfect. So today I will speak briefly about Subsea 7, give a quick introduction about Subsea 7 for the one of you who don't know our company. And the main idea is to talk about mooring systems. So I will give a bit of a mooring system installation track record. And in particular, I will speak about installation of an oil offloading buoy that we recently performed offshore West Africa. And I take this opportunity to mention the renewable section where we see there is a future in the floating wind. So I will share a few images on that. Who we are at Subsea 7? We are, as we say here, a global leader in the delivery of offshore projects and services in the evolving energy industry. We actually remove the oil and gas only because the energy industry involves more than the oil and gas. And the idea is that we create sustainable value for being the industry partner and employer of choice in delivering the efficient offshore solution for the world's needs. We are a company which is about, I would say, probably dating back from 1970, with a Norwegian background, a French and a Scottish assembly history. We merged in 2011 all these sets of company and culture into what is now Subsea 7, which is an 11,000 people company approximately, and with a recent turnover of about, I would say, $4 billion. We are, as we said before, all in the area where serve the oil and gas industry, Gulf of Mexico, UK, North Sea and Canada, UK, Norway and Canada, Africa, which is a region I'm looking after as engineering director, and of course Asia, Pacific and Middle East, but also Brazil and Malaysia, Singapore and Australia. Our core values are important here to say. We work with, of course, safety as a primary goal to be safe for our work and our clients, but also integrity, sustainability, performance, collaboration, and innovation. Sustainability was a recently introduced new value, which shows our proactive approach towards the social responsibility to try to mitigate our impact on the planet environment, which is quite important in this climate change, I would say, climate. Basically, we are looking in terms of capability across all the energy life cycle, starting from the early engagement phase, where we have developed what we call a field development group, a set of engineers which is in touch with our clients to try to deliver fit-for-purpose solution at the best overall install value. I would say our sets of engineers, for today we are approximately 1,800 engineers around the globe, including a 35-man team in Lisbon, which is important to say. And we are executing a full EPCI contract. We install all type of offshore fields, from conventional with platform, jackets and deck, but also complete subsea field production, like we done recently in Egypt, thanks to our 40 vessel strong team of offshore fleet, ranging from diving boat to heavy lift. This offers us the opportunity, as we see on this slide, to cover the full life cycle concept, so design, engineer, procure and fabricate, install and commission, but also maintain via the subsidiary, wholly owned subsidiary that we call I7, which do all the IMR work which is required on any kind of offshore fields. And also we are looking into the decommissioning with our specialized subsidiary also called Seaway 7. This part actually, Seaway 7 is also putting a fleet into the renewable due to its very efficient heavy lift capacity. I will give a brief update on our mooring system installation track record. So today we have actually assembled our proven know-how in a main central hub in Houston, where we have made a dedicated mooring installation business unit. But the mooring knowledge is also present in every of our subsidiaries around the world. The main central hub is effectively in Houston. Together, we believe that we have more than 25 years in mooring experience in any kind, prelay, hookup, tensioning, also doing repair and replacement. We have developed more than 60 projects around the world, including North Sea, West Africa, Asia Pacific, and Brazil. And we have installed more or less all type of mooring system, from the shallow water calm buoy to the very complex semi-sub in ultra deep water. What I would say here is a brief overview of our mooring service track record. I would say here you see there is about 17 different type of mooring system that have been installed, from the buoy supported riser, which is a kind of big 2,000-ton floater supporting 22 steel catenary riser offshore Brazil. The floater itself is about 2,000 tons in weight, so it's a massive structure which is actually submerged at 200 meters below surface and moored with 4 tendons, including 4 extra tendons for redundancy. And we've been installing also FPSO and TLPs and various stuff. Yeah. I give here a few examples of projects that we have been executed. So this one is called Blind Faith in the Gulf of Mexico. The client was Chevron. The water depth here is 2,000 meters, and it's I would say a mooring system, semi-taut mooring system installed with suction piles, suction anchor piles in this water depth. Generally, that's the type of pile that we are using to secure the mooring line. And it's a mixture of chain, bottom chain, and polyester segment running up to the hull. Yeah. The contract for us include also, I'm talking about mooring, but it does include the wet tow from the shore to the offshore site, including so the station keeping and the mooring line hookup. Yeah. In addition, for this one, we were also contracted for the hull dry transport from the fabrication site to the Gulf of Mexico. This project, Thunderhawk, is also in the Gulf of Mexico. I made it here to show that depending the water depth, also this is 2000, 1008, so very similar water depth, but probably very different style of seabed. Here we have used driven piles to the contrary of suction piles, and you can notice here the receptacle here, which will be used to connect the final mooring leg with the boat ground chain, which is secured approximately halfway from the pile for taking the full advantage of the seabed and the soil resistance. Yeah. This project was installed in, as I said, 1008, about 10 years ago. It includes 12 mooring lines with same chain, bottom chain and polyester cable segment. Yeah. It did include the wet tow from the shore to the offshore site and the mooring line hookup. Yeah. This project is actually a different type of floater, the 10 FPSO. It's in Ghana, West Africa. And for that, as I said here, it's a transport and installation of 9 mooring lines, suction anchor piles with also chain and polyester segment. It did include the final tow of the FPSO to location, the station keeping, of course, and the final connection of the mooring line to the FPSO. Yeah. As I said here, it was executed including 4 geographical locations. It is quite often that in Subsea 7 we use not only our Houston main office, but we share the work between the various offices, and Lisbon being one of them recently, for example, but we do share the work between Houston and Paris or Houston and London, depending on the client and other parts. Yeah. And this FPSO was installed using vessel of opportunity, which are named here, but which are not part of Subsea 7 fleet. Norman Installer is a well-known vessel from SBM, which is really specialized in installation of the mooring anchors. Here you can see the picture of the suction anchors, which are actually deployed directly from the deck of the Norman Installer. Yeah. And the Olympic thus was used to deploy the chain and the mooring wire. Yeah. The next slide shows the more recent operation that we have performed on the Jubilee FPSO, which is also in Ghana, and which shows a bit of our success in having repeating order from the client. Yeah, we have here the Tullow client was Tullow. On this one here, due to the fatal breakdown of the FPSO turret, the client has decided to actually install a spread moor system, which necessitated the installation of additional spread moored mooring lines. Yeah. This anchor this time were what we call SEPLA, which is suction embedded plate anchors. You see here the suction caisson, which is used to embed the plate anchor at depth before the installation of the mooring line. Yeah. And on that one, we used also for the installation of SEPLA, the Olympic Zeus, so which is not shown on the picture here. But here you can see the Norman Installer, which has been used to install the mooring lines. Yeah. So that was quite a project, which was executed, here it says called 5 geographical locations. On that one, definitely we had engineers which were from Lisbon, which were dedicated and following the work, together with engineers located in Accra, in Ghana, to support the local content part. And these engineers were actually were sent quite for some time to our Houston office to be able to support this information, this procedures development and offshore operation. And that was a brief overview of the type of system we have installed in the past, which shows our wide experience. And I will go into more detail in the installation of an oil offloading buoy in Africa, in West Africa, which is actually on the same field that we just talked about, which has got this FPSO where the turret has been permanently damaged. The client has decided to install an offloading system composed of 2 22-inch rigid pipeline lines, which are connected to an offloading buoy here, which is an APL type, which is with a semi-taut mooring system shown here along these lines here, and with the repartition of the mooring line I showed on this slide here. It's a 7 mooring line system with 4 2x2 on the wind. And the wind and waves are mainly coming from this side here, and then a 1x3 on this side here, which is, I would say, more benign weather. Let me go back to my text here to see if I'm not missing anything. The mooring line composition here is a ground chain of about 150 to 180 meters, mooring wire segment, which is a spiral strand sheeted wire of about between 700 and 900 meter long, depending if it is short line or long line. And then a piece of two sections of connecting top chain, one 15 meter section which is connected to the wire here, and a section of 30 meter which is pre-installed and connected to the buoy. One particularity of this system here is that the mooring system is a fixed line type device here. There is no adjustability possible from the buoy. There is no pulling winch or no I would say chain stopper, which allows for the chain catenary length here, or the mooring line catenary, to be adjusted on the buoy. The chain, the length of the mooring line is decided upon once the suction pile is installed, and the bottom chain is then cut to the required length for the buoy to be sitting in place after here. And of course, one of the difficulties is to perform the connection at the top here between the pre-installed mooring line and the top chain, which is connected to the buoy. So the way we performed that job this time, we used, I mean, just to give an idea, maybe I can be a bit more precise here in terms of dimension of the buoy here. It's roughly a 2,000-ton mass buoy, which is 31 meter long and about 20 meter mooring, 20 meter wide. How did it work here? So first, what we did was the installation of the anchor piles, which were deployed this time with our vessel 7 Borealis, which is probably an overkill to install that, but we the opportunity that the vessel was here on the location to install the offloading lines, and this was installed by this barge here, to install the 7 piles that we needed for this particular mooring system. So this is shown from the main crane of Borealis deploying with the auxiliary hook direct from a transport barge. Yeah. The anchor are about 20 meter height, I would say 4.5 to 5 meter in diameter, and about 100 to 120 ton in weight. Yeah. Deployed in one shot at location, and then sucked with the ROV directly onto location. Overall installation, so this mooring line we can probably see somewhere here. You see it, there is a connecting pada here, and then this chain, which we call the connecting chain, is secured on top of the anchor, on top of the anchor here, which you can show on that side here, with an H-link, which is then connected with by an ROV to the to what is going to be the pre-installed mooring line. Then the second operation, which is a bit concomitant to the installation of the pre-installed mooring line, is the towing of the buoy, which is performed. So the buoy was fabricated in Lithuania, and transported by heavy lift cargo down to Ghana, where it was offloaded in Takoradi Harbor, which is the closest field, closest port to the offshore field. Yeah. And then it was towed with a couple of tugs, lead tug and trailing tug, to location. Nothing particular here, except that we needed to do a proper ballasting, so the buoy was not rotating in all directions, and the towing speed here was achieved around 3 knots. Yeah. So the way we then after once the hawker and while this buoy was being towed, we pre-installed the mooring lines with the Scandi Skansens, which is not one vessel from our fleet, but a very powerful anchor handling tug equipped with a suitable 250-ton crane. Excuse me. So what we see on our picture is, of course, we deployed the first 180 meter chain, which prior to deployment was cut with a few links. I mean, we cut, I think, to the maximum. We cut about 10 meters. But on some chain we cut only a couple of meters, so that's pending where we install the mooring piles. Yeah. So the chain was deployed first, and then immediately connected to the spiral strand wire, which was paid out for from the working winch from the installation vessel here. And you can see here the H-link, which is ROV operable, which is going to be connected to this particular link here, which has been put in standby when we deploy the pile. Yeah. Once the mooring link, the H-link is secure, we lift up a bit this chain to take it off this standby location, and then start deploying the mooring line towards the buoy. Yeah. So that was done using the Skansen as I just described. Yeah. And then the mooring line was temporarily laid on seabed while we were installing the next mooring line. Yeah. The second thing we needed to do, and maybe I need to, second thing we needed to do was to, once the buoy was on location, we actually removed all the 30-meter long chain which were secured alongside of the buoy, which we don't see here on this picture, but you can imagine here on each cluster we had three or two and two pieces of chain which were secured along the buoy. And then we recovered the buoy was hauled in in position by the tugs, and then we connected the mooring line, which we recovered from seabed, to this second section of the buoy. The tricky bit here, as I said, is that there is no possibility to adjust. And as you can imagine, so the first part to connect, we connected first one short line, another short line, and then we went to connect the next long line to secure the buoy in position. But once this, then after we connected the second short line and the third short line, and at that stage here, you can imagine that when there is a buoy only on 3 mooring line, it was quite easy to move it around to be able to connect the two sections of chain together, which this operation is done on this deck here. But when we come and when we reach to the final mooring line connection, then the tension, the buoy station keeping is stronger, and it did require the help of a couple of tugs to pull the buoy towards the the Skandi Skansen, which was backing off once he had recovered line, backing off closer to the buoy to be able to connect. We show here on that figure the Skandi Skansen coming back here with the mooring line attached to from the stern roller here, so you can imagine vertically going down to seabed here, and then this couple of additional anchor tug, which were pulling the buoy towards the skansen, so that the skansen didn't have to pull too hard onto the mooring line. I mean, at that stage here, we show the calculation of 70 metric ton backward pull, which is not every tug can do that. I mean, the skansen has 360, I would say, maximum bollard pull, an operational bollard pull of about 280 ton. But a max reverse bollard pull of 84 ton. Yeah. You should be careful when you consider working with a tug. A tug normally works forward and not backward. Yeah. So that was a bit of a strange thing that we need to take into account during the final connection. Yeah. But you can see here during the pull, we to be able to reduce the effort in the tugs, we were needing to maintain this close distance between the back of the tug and the towing line, and to be able to reach as close as 12 meters to the buoy to be able to do this connection on deck without too much tension in the line. Yeah. In the end, I think the 70 metric ton ended up to be a bit less than what we thought, probably because of favorable wind and current condition. We were around the 35 to 40 tons, so that was quite interesting for us. Yeah. But all this work was performed, the full connection of the 7 mooring line, in approximately 4 days, when the installation of the pre-installation of the 7 mooring line was also roughly a bit more, 12 hours a shot, and including the same time approximately for the installation of the suction anchors. So overall, offshore operation probably 8 to 10 days for the anchor handler, and we were around 4 days for the 7 Borealis to install the mooring lines, the anchor lines, yeah, which was quite fast, I would say. Okay, and this conclude the presentation of our work that we performed in West Africa. I will use the remaining 2 minutes of my time, okay, I almost went a bit over, to give a quick introduction on the renewable market. Floating wind is coming, and that's why I wanted to talk about mooring installation, because I think it's important in the floating wind to perform the right mooring. We have a fit a bit in both camps. Of course, Subsea 7 is an oil and gas company, and thinking that we should serve our client in the oil and gas, and we see them being more attracted by using the opportunity to anchor nearby to their facility a big wind turbine, which will provide them with a bit of energy to handle their all the equipment which is on the production platform. Yeah, I think it's a good transition in our part. As I just said, we are today well engaged into the renewable with our subsidiary called Seaway 7, pardon, which is mainly today concentrating on the fixed wind farm market by installing transition transition piece, but also foundation. That's the main work. And also we have an interest into installing inner array cable with our subsidiary Seaway Offshore Cable. Yeah. As we see, floating wind as definitely some kind is picking up. It's not going as fast as the fixed wind. There's quite a few projects around the world, and we hope that this is going to be even more in the future, so that we can benefit from the technology that we have deployed today and continue with it for the benefit of the energy industry. Yeah. And that's it for my presentation. I will open the floor for question and stop sharing my screen.
Thank you, Marin. Thank you for the presentation. We have now 5 minutes for questions. I will start with okay. Before the questions, I just want to make a note that for the audience that wants to make any questions for the presentation, there is a question mark on the right corner up of the software when you can click to submit your question. There is a question mark that you need to click on. So the first presentation that we have is based on your huge experience on the mooring system. Can you identify the three top activities that need to be revisited to reduce capex?
Yeah, I would say it's quite important to select the right anchor. I would say, because you can see there is suction anchor, there is driven pile anchor, there is a Sepla, there is drag anchors, and all depends what type of seabed you have around you, and what will be the less I would say expensive both to fabricate but also install. So that's one part which is important. Yeah. Then after, I would say, of course, you need to do a good selection of your mooring line component, and try to understand what is the I would say best equilibrium between all the connecting bits you're going to put into the mooring line and its installation. For example, here on that one, the installation that I just described, we had the possibility to introduce this H-link as in between the mooring anchor, the anchor itself, and the mooring line. This offers you the possibility to decouple the installation of the anchors, which sometimes is intensive in terms of a vessel, because it requires a specific vessel, like deploying large suction anchors requires a large crane capacity vessel. When you can effectively, so if you manage to decouple that, you can pre-install your anchors on, I would say, when the Borealis, for example, for us, it was an opportunity. The vessel, the Borealis was here, just install this, and then later we could install the line with a lower class anchor handler, which decrease the overall installation cost, which in the end is a capex. Yeah. So I would say that that's an important point that we need to figure out. And as you saw on this APL buoy, there is no requirement for installation winches and things like this. And I believe that this is something attractive for the future. So you need to consider these three elements. Yeah. I would say the anchor, the mooring line and mooring line details, and the way the line is connected on top of your mooring system. Yeah.
Okay, thank you very much. We have a second question. Is related to seabed trenching. Have you, during your experience, have any problem with the seabed trenching on the mooring lines, on the chains in the bottom?
I would say effectively we see that if the line is very often we see that actually more on steel catenary riser than mooring lines. In my experience, personally, I have not experienced detrimental seabed trenching in terms of the line is actually embedded too far, and then after gets kinked because it has created itself a big trench. Yeah. I have not been. It's not so critical for the mooring lines as it could be for the steel catenary riser, for example. Yeah. Which do have a tendency to embed themselves and to trench themselves down. Yeah, yeah, true. Okay. But not for the mooring lines, never.
Okay, thank you. One last question, 1 minute. Can you present any lessons learned from the LISA project that Subsea 7 has installed? Because you have suction piles in there, if I'm not wrong.
In the RISA project, in this project, we installed suction piles. Yeah, in this particular project. Yeah, I would say the main lesson learned for us was have a good preparation. It was quite important that we made our preparation, and we did a lot of I would say testing before we actually went offshore to make sure that the H-link was in a good position, the ROV have good access, it could disconnect and things like this. So that was quite important for us. Yeah. I would say that's probably the main lesson learned. Get well prepared, and the operation went absolutely smoothly. This operation went actually even smoother than what we thought. Yeah. So that's a good preparation is very important. We had I would say on that particular operation we had the good opportunity that the Skansen had installed previously the same type of buoy for another contractor, and actually they were quite impressed with the way we have made up our procedure, and they help us a bit improved, but we were quite prepared for the operation. So quite important to have a good preparation.
Thank you very much, Marin. We are above the next presentation, but once again, thank you for the presentation.
Pleasure. Thank you very much.
Okay.
Good meeting. Yeah. Bye bye.
We are going to proceed with our fourth presentation. For that, we are going to have Senem van Rijsewijk. I'm sorry if I'm not pronouncing it correctly because it is extremely difficult to me. She is the Senior Business Development Manager at Ocean Infinity. Senem is a geophysical engineer by education. She has started her career as geophysicist at a software company in oil and gas industry. She has worked over 10 years in processing and on-site support teams before moving to account management of UK and Turkey markets. Currently, like I said, she's working as a business development manager, covering our clients from the eastern region, and she is going to present how to acquire high-quality data at very large scale in the safest and most sustainable way possible. Please, Senem, the floor is yours. Thank you.
Thank you. Thanks a lot for the introduction. I don't know if I can just share my screen right now, and do you hear me well?
Yes, please share your screen. Yes.
Okay, perfect. One sec. Do you see my screen?
Yes.
Yes, perfect. Perfect. So good afternoon, everyone. My name is Senem van Rijsewijk. I work at Ocean Infinity. And first, I would like to thank Galp team for this opportunity and for you to join us this afternoon. Today, I would like to introduce you Ocean Infinity, who we are, what we do, how we acquire high-quality data, very large scales, and safest and most sustainable way possible, and how we can bring more values to the project. Today, I will cover these topics very quickly. Ocean Infinity is a marine robotics company. So we acquire large scales of and high-resolution data, safest and most sustainable way possible. We have 3 core strengths, and 1, scale, precision, and speed. 2, sustainability. 3, our team. So I will first talk about this very briefly, and I will go to the technology more in deep. As mentioned, first core strengths we have scale, precision, and speed. The way we can achieve this, we operate worldwide with 3 vessels, and we have multi-AUVs on them. AUVs is standing for autonomous underwater vehicles, and the simultaneous deployment of these multiple AUVs allows us to scan through the seabed very quickly and very precisely. To do that, we need the best team possible, and we have full of experts of our team. And this is actually the first company to deploy multiple AUVs and USVs at this scale. So we need a very good team to achieve this operations. And our team contains of operating this advanced technology from the start, from mission planning to the data delivery. And of course, having the safe, efficient operations, we need to develop comprehensive sustainability and safety procedures. For us, the most important thing, of course, our team, our customers, their safety, our contractors, all the people working with us in our projects. Safety is very, very important for us. That's why we have procedures, stop the job policy, and trainings on that. And sustainability is the heart of what we do. So our aim is to do minimum impact on the environment, but by what we do. So our host vessel acquires materially less fuel, so we have far less impact on the environment. Using multi-AUVs, we finish projects much quicker time and using much faster and lesser carbon dioxide emissions. So this picture might be a bit of out of the context, but it's actually not. It was a footage. This is a screen from a footage from an expedition from Antarctic. And we collaborated with a university to do, in the vessel sea, to study climate change. So we use multiple AUVs, and we use our AUVs to go under ice and study the climate change. Ocean Ingenuity services can be grouped as two. We are very known in salvage and wreck industry, so we actually help people to locate vessels or find whatever they are looking for. But also for energy industry, we analyze, we provide very high resolution data, very precise data for our customers to empower their projects. But how we do this? We do it by our autonomous underwater vehicles, which is AUV, and we have 15 of them. We are operating and doing three vessels, so we have 5 autonomous AUVs in our each vessel, but we can put up to 8 AUVs. So they are capable of achieving up to 1,500 kilometers square per day, and their operating depth is from 5 meters to 6,000 meters. So deploying multiple assets, that means we are using less fuel in our host vessel and having a far lower impact on the environment. Actually, I will mention it in the case studies, but for Malaysian Airlines project, we use 8 AUVs and 8 USVs at the same time. So with USVs, it's unmanned surface vehicle, as you know, and we work with them in the shallow part of the operations, shallow water areas and inspections. They're very environmental friendly, burn less fuel amount, and they're faster than AUVs. Of course, we also work with world-class ROVs, and we use them for especially for inspections, maintenance and repair, core sampling, fixed leakage, and pipeline route surveys kind of jobs. And for Grande America, I don't know if you know, but it's actually a cargo ship sank in offshore France around March 2019. So it was an urgent project because the cargo ship had around 365 containers, and more than 40 of them has hazardous material in them. So we got this emergency call, and our vessel went there. We found the wreck with the first AUV dive, and our world-class ROVs worked continuously 249 hours and stopped the leakage. That was around 4,700 meters water depth. We are operating 3 vessels around the world. The names are Pacific Constructor, formerly Seabed Constructor, Island Pride, and Normand Frontier. This one on the picture is Island Pride. They are all very similar to each other. It's around 110 meters to 115 meters long, And they all have 5 AUVs, 2, 3 USVs, and two world-class ROVs on them. You may see this area on the deck is quite big, so we can have actually more equipment for the project if we need to, like geotechnical sampling equipment and so on. And we have helipad, moon pool, of course, and these vessels around 100 people accommodation, and they have real-time data processing center in them. They are multi-purpose vessels. So we can have a mineral project, or afterwards we can have a oil and gas project. That's because our equipment permanently on the vessel, and vessels are multi-purpose. We don't need to go to the shore and come back and between projects. Our operation time is 42 days cycles. So that allows us to remote and long endurance projects. Also, there are DP2, so dynamic position 2 vessels. Of course, using multiple AUVs and USVs, we gathered a lot of data. To work with this data in a very efficient way, we need to have a very good data management system, really good software and hardware on the vessels as well. And we use smart cloud technology to lift the data off the vessel to produce much faster reports. And also we develop artificial intelligence, deep learning, and to optimize the processing, to reduce the manpower and offshore hours. Our aim is to AUV processing turnaround time, onboard 24 hours post data downloads. So thinking about all these, we actually did a lot in a very short time. So we started with 1 office and 6 AUVs around 2015. You might heard about us due to Malaysian Airlines search, MH370, which I will mention in the case studies. Our first commercial survey project with Woodside Energy. And we also worked together with Kraken, and we use their batteries for getting more out of our AUVs. And we have much faster and high technology AUVs and batteries you're using. I will mention also in a bit. End of 2018, we located the missing Argentinian submarine, Ara San Juan. This is actually a very important project for us, and there were 27 ships, 11 aircraft, and 7 countries were looking for this missing Argentinian submarine. And we found it in a very complex bathymetry area, around 950 meters down water depth. And we had 60 crew members and 4 family members from the Argentinian crew and 3 officers from the Argentinian Navy when they were observing when we were doing the research search operation. And we found their resting place. And this is still a very important project for us, of course. Then we increased the amount of AUVs. Now we have 15 of them. And there's another milestone with Petrobras project we have. We are currently working with Sepamar, one of our vessels offshore Brazil. We are providing high-resolution hydrographic mapping services for them. And also, of course, we have more projects after this with Total, which I will mention in the case studies. Currently, ExxonMobil Guyana project, and we work with NPD and more projects coming up. The markets we are interested on, of course, offshore energy is a very big part of our job, submarine telecommunications, minerals, government defense, academic researchers, and salvage and wreck archaeology markets. But what is the advantages of multi-AUV? Why we are using it and why I'm talking about this? Because we reduce the offshore manning by 75% comparing to equivalent production using conventional methods. We have shorter project times, and sustainability is increases because we are using less fuel, so it's very environmental friendly, and we can do simultaneous operations. So while we run our AUVs, we can have ROV inspections and also geotechnical investigations at the same time. But I think one of the most important things, some of our competitors might have one AUV, and it might, if there's something wrong with it, it might delay your project, or it might even cancel or just postpone the project. So in our case, because we have multiple AUVs, we always have a spare one in our vessels. So if there's a problem with it, we can always bring the spare one into water, take the problematic one out of the water, and we can fix it because we have a very great team. We can maintain our AUVs and fix them while other proper ones can run the job. So there's no downtime time. So this is just a few advantages of using multi-AUVs. Going to more technology and equipment, this is how it looks like. So this is how the AUV and the sensors, but the most important thing here I want to talk about, we are using, working together with Kraken and have more advanced batteries right now. We used to have used AUVs for launch and recovery up to 60 hours per operation, per 60 hours. But with these ones, the new batteries, we can run AUVs in one go, including launch and recovery, up to 90 hours. So that really affects our project time and makes them shorter. These are some of the sensors we can use, and depending on the, of course, project needs and whatever we would like to do, we can change the sensors and we can make customization with them. I don't know if you can see the video. It's a very short time-lapse video of our AUV operation. This is our hangar from one of the vessels. They're all very similar. They can hold up to 8 AUVs, and you can see how they launch one after the other. So this is actually a good example to show, because if there's any limited weather downtime, if we can put them into the wait pattern and we can continue after that. Saying that with our recent NPD project, Norwegian Petroleum Directorate project, we didn't have any weather standby time. Of course, depending on the project needs, if there's any low resolution data needs, we can use our hull mounted part of it. We have hull mounted underneath our vessels, and you can see on the right, it shows the AUV mounted and hull mounted low resolution and high resolution parts in the graphics. The picture shows you how the vessels have underneath the hull mounted. We have 2 of them, and the third one will be planned for this year to put under our third vessel. And we use them mostly for sea punting surveys or mining slope elimination, cable route surveys, and so on. And this is a good example to show the difference between satellite gravity measurements, altimetry data to hull-mounted EM122 multi-beam data. You can see the difference here. And this is a very small schablon to show the Hugin, the AUV, and how the actually coverage shows the coverage. So underneath, the orange part shows the multi-beam and backscatter infill, and the side ones, the blue ones, show you the sub-bottom side sonar scan areas underneath, so the coverage can be seen in the diagram. And our USVs are operating to sea state 5, and they're quite fast. But I will mention the new upcoming business unit related to that at the end of the presentation. I hope you're gonna like it. The ROVs, we mentioned the world-class ROVs we have. We mostly use them also for the live stream from ROVs to the center room. So we can see what's happening at the same time. We can see the seabed very clearly and what's on it, and analyze it very quickly with our ROVs. I think one of the most important thing our mission is the AUV part of it, because using multiple AUVs at the same time is very, very important. So these AUVs, we need to plan it properly, and of course there are some challenges like simultaneous operations. We get them solution by our software called Infinity View. So they show us the dynamic inputs and how the AUVs are going, how they are moving, and also it can show us if there's any hazards. AUV is very clever to avoid the hazards, and but the mission planning is very important, and our own this software is specially designed for Ocean Infinity. And of course the case studies. We start with Woodside. It was a time-sensitive project. It needs to be really quick, and it was winter time in Australia. Water depth from 100 meter to 1,500 meter, to 280-kilometer pipeline route from field to shelf break. And we use AUVs, multiple AUVs, ROVs at the same time here as well. The good part with this, actually, the client was really happy because we were showing them, okay, how is it going? And they could make adjustments while we are doing it. So the route development decision made during the project. So actually they made more efficient routes while working with the project. And comparing the results is fascinating because we use some of the parts, we use up to six AUVs at the same time. And you can see here, if this project has been done by the traditional method, it will take 70 days traditional 1 AUV operation, comparing to our project finishing 20 operational days. So the efficiency is almost 4 to 1. And Total Angola. So we finished this project, I think recently. It was a 28 days project from Normal Frontier, and we conducted to the ultra high resolution seismic survey and seabed soil sampling in blocks too. The most important part of this project, we gathered geophysical, geotechnical, seismic data at the same time. So this is very important because this is the first time is actually this geophysical, geotechnical, seismic part acquired at the same time from one operational vessel at the same time. So this, because of that, and also the operational performance and HSE performance, we get certification for 28 perfect days from Total Angola team, which we are super proud of. And the search for Malaysian Airlines 370. This search started around January 2018, so with Malaysian government, and it's one of the most difficult places in the world because the southern Indian Ocean, so most remote locations is actually, and we covered the area much quicker than rest of the companies. As you can see, we covered around 125,000 kilometers square in 4.5 months, like 4.5 months, with one vessel using 8 AUVs. And the same kind of area has been searched by 27 months of operations, while with 3 deep tow vessels and 1 AUV vessel. So the comparison is a very interesting comparison. And you can also see the fuel consumption and the carbon to emissions, the differences. between our operations and an average survey vessel, the differences. For the HSERs as well, comparing to 138 days to 837 days, and the R's is there's a lot of difference. And not last, but a new development are Armada. So we talk about Infinity Fluid, but we are also now doing a new business unit. We are building new boats, and our aim is to have no host vessel and no one at the sea. So it's up to 90% emission reduction. So this new fleet of us will be called Armada under Ocean Infinity brand. They will we launch it in February, and they will be all unmanned vessels, and we are thinking to have, they are capable of shallow water and deep water survey, as well as ROV, AUV, UAV payloads. So hopefully, when they're up and running, they will be operating the largest fleet of low-emission multi-role robotic ships. And it will be similar to this. Of course, they are still building up, so it might look different, but this is the current images. The sustainability part is very important for this, because a typical 21-day offshore campaign, the differences between, on the right, you can see Armada 21-meter robotic ship, difference to conventional 65 meters vessel, the difference you can see in the emissions. And of course, the advantages will be, we will be able to transport them in the world and different places, even by air. And they will have ultra-speed data collection, 0 people at sea, insurance with the safety, of course. And there will be a lot of quality data to gather faster and more efficiently. And with Armada boats, we are hoping to answer these sectors' questions. So thank you so much for your time. Thanks for listening and joining me. I think we have still some time for some questions. I hope it wasn't too quick, but you can always reach me from my email, from my contact numbers. I will be happy to help.
Thank you, Senem. Thank you very much for your presentation. Yes, we still have some minutes for the questions. Once again, somebody that wants to make a question, on the question mark on the top right, please. The first question is related to the data transfer. The data transfer is usually done by public submarine network. So, considering this, how can Ocean Infinity ensure cybersecurity?
Cybersecurity is a good question. So basically, we bring the AUVs back, and then we take the data out of it. So it's in our vessel. Everything happens in our vessel. Of course, it's a very secure place, and we have good secure IT system that we always basically improve. Of course, there's always room to improve, but I'm pretty sure we have good examples I also showed you, and hopefully we will gather more, expanding our portfolio as well. I hope that answered the question, but you can always contact if you want to ask more.
Thank you. Just one more question. You mentioned that you are using artificial intelligence development. Is it internally, or do you have partners for that?
I think it is internally, I think, but I can check that one. Because some of the, like Infinity View, for example, for our missions, it's designed for us specifically. But also we have our team for developers as well, but we can definitely check it. The one I've mentioned is mostly our people designing and make sure that we are making everything on top of very advanced level.
Okay, thank you very much once again, Senem. We are going now to end up, close out this session. For that matter, I will pass the word to Igor. So Igor, please come forward.
Thank you very much, Bruno, for the brilliant commitment in this event. And thank you, Senem, for the intervention and the talk. So
thank you so much for inviting us as well. Thank you.
Thank you so much. So we have finished the first day of presentation into room 4 of the 7th Galp Open Day. We would like to thank you all the attendees in the event and the very interesting presentations. And we will be pleased to have you here tomorrow at 2 p.m. on room 1 for the debate of digitalization and innovation. So it will be another day of brilliant talks. Thank you so much for everyone. Thank you, Bruno, and thank you, Stan.